Okay, yes, I remember now. So these are two dip wells at either end of a long transect. So we've calculated against ordnance datum what the water level in the well is, and then the people on the course have been out and taken some samples midway between those two wells, and so what we've done is averaged those two elevations to give the water table elevation underneath the samples that were taken. So that is now yes, we've changed units here. That's elevation in meters. This is now the water table depth in centimeters. So on the 12th of December, the water table beneath the point of interest is 6 centimeters. I can see why I did those columns now. So what this column is doing is using a threshold depth of 15 centimetres for the soil for the aeration threshold, and it's simply saying if this is shallower than 15 centimetres, then you give a 1 to show it's a wet soil. You've got potential aeration stress, and then this is using the soil specific threshold of 47 centimetres for soil drying, and so we're getting a 0 because that doesn't exceed 47, and therefore it's not a dry soil. So for every reading, and these are 4 hourly readings, so it's a very long list, it's a bit dull, but you're clicking up yes, it's a wet soil up until Christmas Eve, when suddenly the water table sinks from 14 to 15 centimetres, and so you're getting 0 now. It's no longer aeration stressed. So you've got both columns 0 through till 12th of January, when it must have been a rain event and has wet the soil again. Go faster. There we go. So we've got into May before you've got soil drying. So it looks like the 25th of May was the first date when you've hit this 47 centimetre threshold, and so you started to click up 1s in this column now to say the soil or vegetation is potentially exposed to soil drying stress. So that carries on right through till June 2010. So that's 18 months worth of data. And what this bit at the top is doing is calculating for all the data and then correcting on an annual basis. So it's saying, given that data set, the number of weeks of wet soil you have during the year are 12, and the number of weeks of dry soil you get a 23. And then what we did was a separate transect, exactly the same thing, but now we're using wells 5 and 6 with the same process, using the same thresholds because it's on the same site. Again, clicking up when you're getting above the surface or above the aeration threshold, and then in this column when you're below the soil drying threshold. And this time we're getting 26 weeks in a year where you've got wet soil, but only 9 with dry. contrasting with that one. So this is clearly the drier regime, this is the wetter regime, and that ties in with what the botanical is saying, that this is an MG, classic MG4 community, that's an MG8 community. So that's the simple calculation for durations. If we step that up to some exceedance value, it's slightly more complex. Here we have students' data V, where she's got 3 wells that she's reading every fortnight, and for the period of the growing season, which is this column, so we're only doing the calculation when we're between March and October basically. And here are the soil drying thresholds, 44 centimetres, and the aeration thresholds, 34. So this is in fact Pilchfield in Buckinghamshire is a very fine textured soil, so you need a deep water table to aerate the surface. So she's calculated the sum exceedance for soil drying. If I just put the equations up there, it's testing whether this value is indeed below the threshold. She's using negative values to mean depth below. So this is surface water where it's positive, and this is the depth when it's gone negative. So here we have 73 centimetres. It is greater than the threshold. Just taking that as the threshold. So 73 minus 44 is 28. So on that particular reading, you've got, if you like, 28 centimetres of exceedance, and then she's going through and you accumulate these by adding them up, and she's got that for the next well and the next well. Okay, so you can see they vary as the water table's in the 70s there. You're getting values, exceedance values of 20 centimetres. Then in August it's dropped lower. In fact, it looks like it's dropped to the bottom of the well, because she's got constantly 86. Well, this well was obviously a bit deeper. We're getting constantly 95s, but we're only getting 40 in this column, which doesn't quite add up. 95 minus 46 isn't 40, but how that has come about is this little bit of the equation says if the result is greater than 40, then you just set it to 40. And that's what we call the cap, so that we don't keep accumulating. And in these sorts of soils, the soil is so unstructured at depth, water table doesn't really mean very much. It's so fine textured, there aren't any big enough pores for water to move. So there's sort of, if you sunk a well in there, in summer the water table may drop very quickly, because the drain porosity of the soil is so low, there's so little water needed to evaporate to drop the water table.